So yeah, hello. Thanks for introducing me. Once again, I'm Kremser. This is my bio. I came here from the Czech Republic. I drove here actually with my family. It took me 9 hours. And I currently work as a software engineer for Red Hat, but soon I'll be working for Oracle, I think in 2 weeks or so. And yeah, the slides are online. It will be online, also available at the end of the presentation. So I'll start with a question, like how many of you are familiar with Kubernetes? Can you please raise your hands? Awesome. It will save us some time because I'm kind of assume some knowledge of Kubernetes. So Kubernetes, for me, I take it as an orchestration platform for containers, for assuring that your containers can talk to each other, and for managing Dockerized world, basically. It contains a couple of resources, such as the main notion is pod. It's like unit of scalability, services, some higher level resources like deployment, stateful set jobs. And if you work with Kubernetes for some quiet time, you may end up with something like this. This is real life example of something I called YAML hell. It's a state when you have a lot of lines of code encoded in YAML, and it's very hard to maintain it, develop it, or actually make sense of it. Because if you, for instance, work with Istio, there are similar YAMLs that have like 2 kilometers length. And this is actually a YAML from a project called Oshinko, which is a CLI client we developed in our team for spawning Kubernetes cluster. It was replaced by the operator because operator solves this like unnecessary complexity by hiding the implementation details. So what is operator? It's a design pattern introduced by CoreOS guys. We at Red Hat acquired CoreOS, I think it was 2 years ago, and it extends naturally Kubernetes because these days Kubernetes, the core of Kubernetes is pretty much closed, and the only or the suggested way of extending Kubernetes is by introducing your own types to it. It's called custom resource definitions, where you can basically represent whatever you want in the Kubernetes cluster, and it will create an etcd table for you where you can create those new things, query them, edit them. But to be able to work with it properly, you need something called controller that reacts on events when those custom resources are created. So custom resource definition is a type, and custom resource is an instance of this type. So operator is a custom controller that reacts on events that are coming from basically creating, updating, and modifying or deleting those new custom resources. It will make much more sense when I show you the example. So operator of type X, it has a task to monitor or to react on events of type X. Will first, when it's deployed in a Kubernetes cluster, it will register something called watcher, and will say to Kubernetes API that, hey, I'm listening on the new custom resources of type X. Kubernetes API say asynchronously, okay. And then if a new custom resource of that type X is created, it will notify the operator, and now it's the job of the operator to do something about it. Most of the time, it will deploy some resources to the Kubernetes in any replicas or whatever you want. In Spark cluster, in Spark operator, we will see it will deploy a Spark in standalone mode. And then after some time, because it should also cover the whole life cycle of the X, it should take care of all the resources, because then if the user comes and it will delete the custom resource, it's task of the operator to clean the resources and basically, in our case, undeploy the X, because it's a general example. So to compare it with other similar strategies, how to deploy something into Kubernetes, well, operator is much more than deployment mechanism, but it has huge overlap with what it can achieve with some other technologies. So I've shown you the Kubernetes manifest, which is like the base layer of how we communicate with Kubernetes, but it tends to be pretty complex and long. There is Helm charts. There are Helm charts which are nice, but I don't like that they combine the declarative approach and the imperative approach when you can specify conditions and mix them with declarative paradigm, like what you're mixing how and why, or what and how actually. There is Ansible, which is also a deployment mechanism, and there is a Ansible role for Kubernetes where you can specify those YAMLs, you can parameterize them, you can run all the Python machinery with the Jinja templates, and it just works. And to be complete, I have also customized, which is, I like customize. It was adapted by Kubeflow, I think, and KSonnet. It's also an option. This is like minimal example of the operator because I like to demystify the operator pattern. People often think that it needs to be run in Go language, but it doesn't. This is an example written in Bash. It's pretty simplistic. What it does, it just waits on new events from the newly created config maps, because there is like infinite while loop. And if it get the event, it can do something about it. I've omitted the body of the operator on purpose, but it's the idea. It is some kind of watcher that can react on events, event-based system. This is the example of Spark operator in a nutshell, summed up in one picture. So there is a guy, and he will ask for a new Spark cluster. And what it actually means, it means that creating a custom resource of the desired state of the Spark cluster. Then there is a Spark operator that will come and create the cluster for it, either in Kubernetes or in OpenShift. So I started the Spark operator as a toy project, but now it's adopted by AI Center of Excellence project called Open Data Hub, where it works with other operators actually for Jupyter Hub. So it's like a set of operators where it spawns as Spark clusters, but also Jupyter notebooks for you. And it also provides a way to integrate with Ceph storage, which has S3 compliant API, so you can store the checkpoints of your computations to S3 buckets. You can check the URL. It's open source. It's compatible with Spark operator from Google platform, GCP operator. To avoid vendor lock-in, it's compatible on the schema of those custom resources, but it's written in totally different language. The GCP operator is written in Golang, while this is written in Java. It's also available as a Helm chart, so you can easily deploy the operator itself, and also as an Ansible role. If you have like more sophisticated setup with Ansible, it's pretty easy to spawn the operator as well. And there is also integration with operatorhub.io, which is kind of index of all the possible operators. Well, not all, but a lot of them. And this is how it looks like. This is in the middle there is an Apache Spark operator where you can easily deploy it in your Kubernetes cluster or OpenShift cluster. So what it can do, it reacts on these three kinds of custom resources. The first one is the main notion of the Spark operator. It's a Spark cluster. So if you create a new custom resource with this type, it will spawn as Spark in standalone mode with a couple of replicas of workers and a couple of masters. And you can also specify the configuration in these custom resources. And I will show you the example. Yeah, there is here. This is a very, very basic example where you have a worker in 2 instances with 1 gig of memory. And all the other values are taken from the default values. So it has 1 master. And yeah, there is some default image with container. And yeah, so this is the more complex example where you can also see the default values. So you can, what I like about it is there is a way to describe also external Maven dependencies right here. So you can specify them with using those GAV notation, group ID, artifact ID, version ID. And what it does, it will prepare the dependencies for you on those workers and master. So you can easily explore the data with this kind of, It's not suggested way because it's much more faster if you have all the dependencies baked into the image. But if you want to play with the data, explore new libraries, it's a handy feature for prototyping, actually. You can also override all the configuration for Spark, either by providing it by key value or using a config map, which is like if you have really long your own configuration, it's much better to use config maps. But you can, again, if you want to prototype and play with it, you can put key and value, and it will override the defaults. You can also populate some data on those workers, not only the Maven dependencies, but like arbitrary files, by specifying the URLs and the location where it should download the files. So if you have, for instance, some CSV file, Parquet file, whatever you have, you can use this strategy and it will spawn an init container that will use wget to download the data for you. So yeah, let's. I've prepared a couple of demos. Something will probably break, but I will try. So let's try the first one. It's the very, very basic one where I can deploy the operator. So first, let me show you the manifest for the operator. It contains, the first part is boring. It has service account, which is used for RBAC. This is the user under which we are performing all the actions. Then we are assigning some role for the service account. And then finally, the deployment. And it just deploys this Docker image with those environment variables. And by the way, this is a good example where you can also use in your YAML files to reference some parts and then dereference them. So this is kind of a way to avoid duplication in YAMLs, but it only works for the same it doesn't work across the lists because this is actually a list of different YAML objects, YAML resources, and I can't define it in one node and reuse it in another node, so it has some limits. So I will deploy it by OC apply. OC is, by the way, OpenShift client, but I can do the same with kubectl actually, kubectl. So by applying this list, it will create a new deployment in OpenShift or in Kubernetes. Kubernetes and OpenShift is the same thing, but OpenShift contains more features. So it's currently creating the container. I can check the logs. Yeah, it says that it's already started and it's listening on Spark cluster and Spark history server and Spark application custom resources. So now if I create a new, this is just one pod running, I can split the screen, make the font bigger, and I will create a new cluster, very simple one. So OC apply this YAML. This is the custom resource I was showing. So now the operator should register the new event, and it's creating a Spark cluster for us in two instances of worker and one instance of master. So if everything goes well, it should be running and ready. I can also create a new application with notebook that will try eventually to connect to this cluster. So I'm currently deploying a notebook. It's actually building the image for the notebook in the deploy job, and now it's finally creating the new pod. I can check the logs for the. Hasn't started, but I need the token from the logs. So once it's ready, I can copy paste it and put it in a web UI. I probably didn't pull the images before. Sorry for that. Yeah, finally it's running, and I can take the token and put it. Oh, I need to also expose the route. Yeah, this guy. So this is the URL under which we will get the notebook. And we need the token. I lost it. Sorry. Silox. This is security thingy that allows only those users that knows the secrets to log in. So this is the notebook with some Hello World machine learning in it, and it will demonstrate how to connect to the Spark cluster we deployed with the operator. So to do that, we need actually a service, and it's this one. It has the same name as the custom resource for our Spark cluster, and this is this is how Kubernetes does the DNS of the services that are deployed on it. So instead of creating a new standalone cluster on the same pod, we will try to connect to the existing cluster by providing the service, and it was the default IP, which is 7077. And luckily, if I evaluate the cell, I should be able, actually let me put a cell below to evaluate the Spark cluster again. And yeah, it says it's connected to our newly created Spark cluster. And I can also verify it by looking into Spark UI. So one of the services was for Spark UI. I can expose it. And it should be available under the route, right here. Yeah, and it says that we are connected with PySpark shell, which is basically the notebook application. I can, for instance, also scale the cluster and see if it applies, if it's reflected here in the Spark Web UI. If I make a change to that custom resource, it should produce a new event, and the operator should do something about it. So if I do kubectl edit Spark / cluster, it's a new resource in our Kubernetes, so I can do that. Spark, yeah, right, thanks. And it was called my Spark cluster. I can change the spec inside the custom resource, and if I save it, the operator should, it's killing basically one worker, and now if I refresh it it's like directly scale it down. So it's pretty fast, event-based system, so it was let me also delete it. So it will all go down. Yeah, it's now only the operator is running and the notebook. Let me switch back to the presentation. So it was achieved by an implementation that fits in one slide. This is like the handlers for the events that are produced by query or CRUDing the custom resources. And the other thing that it can support is a Spark application. I'll only show you the example how it may look like. The custom resource on the left-hand side, it's a Python example that uses an NT-LAK library for natural language processing. And these Spark applications are different. These are basically wrappers around Spark submit with this --master KDS strategy that uses Kubernetes as a native scheduling mechanism. The previous example was spawning Spark in standalone mode on Kubernetes cluster, while this uses Kubernetes natively as a scheduler. It's a new feature from Spark 2.3, I think. And on the right-hand side, there is an example that's basically running the Hello World in Spark, SparkPy. And the last custom resource that's supported by the operator is Spark History Server, which is a wrapper around running Spark in like lightweight mode that keeps track of your submitted jobs. It can be handy for if you want to track the history of the Spark submits, basically. This is an example, and we need to first create the Spark History Server, which is the custom resource on the left-hand side. specify the size of the volume for the logs. And then we need to reference it from our Spark cluster, which is the arrow. And if provided if it is backed by like reasonable persistent volume with some reasonable strategy, we require read many, write many, which is not like the production ready, but it can be backed by NFS and it just works. Or the better solution is to using S3 bucket. And we have example for that as well. So it was achieved by using the Fabricate Kubernetes Client, which is a library written in Java that can communicate with Kubernetes. I like it because it provides like fluent API for talking to Kubernetes. It's type safe, so you basically can make a typo in some schema and then figure out in production. It's pretty nice because it can figure out where it is running, and it takes the credentials from the proper destination. For instance, you can write the operator as a pure Java application with java-jar, and it will figure out that it should take the credentials from your, I think it's home.kube, somewhere there. Or if it is running in a container environment, it will take it from the secret. And it also uses something called abstract operator library, because I've refactored out from the Spark operator to allow other people to use the similar library for writing other operators. So to my knowledge, there is one operator for Flink, prototyped by a guy from Lightband. And there's also one for Tomcat, like our productized Tomcat. In Red Hat, we have Tomcat with support, which is operator written also in this library. And I have also provided examples in Kotlin, JavaScript, Haskell, and other languages that can run on JVM, because JVM is the common denominator for like using other libraries. It supports JSON schema as a single source of truth. You described your schemas for CRDs in this JSON schema, and it uses JSON schema to Pojo library to create classes from this representation. Yeah, right. And there is also support for custom config maps. I didn't talk about it, but it's possible to represent the resources not only by custom resource definitions, but also by config maps, which can be handy, especially for OpenShift, because on OpenShift, you don't have root system admin by default, but config maps are allowed to be created by anyone, like mere mortals, but not the CRDs. Yeah, so this is the dependency graph of the operator. Spark operator uses abstract operator, which transitively uses Kubernetes Client. And both of them has like Maven POM parent, where it specifies all the dependencies or the variables to make it aligned. There's a couple of tools around the Spark operator. I've written two of them, and one was written by my colleague. I can show you the SOIT, which is Spark operator image tool. The goal of it is to verify if the desired image will fly with the operator. It has a couple of checks, and it verifies if the image is basically ready for, or I can do that on my own. It's pretty easy. It takes a couple of parameters, and one of them is, of course, the image and tag. And if I run full here, it will write, 19 asserts. It will spawn the cluster it spawn one master, spawn one worker, try to connect them, and verify if it is possible. And it's using pretty cool library in Python that can talk to running containers and ask if something is on a path or verify or other predicates. So yeah, it prints like readily approves in ASCII, and these are the checks that were performed. There's also Ansible role that can deploy the operator. Oops. Oh. Sorry. And Oshinko Temaki, which is a tool for, it's a CLI tool for creating valid custom resource definition, custom resources for the operator. So you can reverse the problem if you want to have the Spark operator part of your automation pipeline. You want to have a way to automate it for automatically created the Spark clusters. So it's much easier to not to create those YAMLs for the operator, but to have a tool that will create the YAMLs for you. It's using Quarkus.io, which is a framework that transitively uses growl VM. This, by the way, the project I will be working on in Oracle in 2 weeks. It's a compiler that can do the similar thing as Golang has by design, which is like one binary that contains everything statically typed, which is pretty handy for Kubernetes world or for containers because you don't need any external dependencies. And you can achieve the same thing for Java application by using growl VM and its ahead of time compilation. It's a pretty cool feature where you sacrifice the platform independence because Java is platform independent by default, but you will get really fast startup and pretty good memory footprint. What it does actually, it evaluates all the static initializers during the compilation, and it creates a snapshot of the memory. And then when you start the application, it will load the snapshot of the memory, which is dangerous on one hand because if you have like date in your compilation time, it will take the date of the compilation, not of the startup. But it's pretty nice. And yeah, normally JVM it's optimized for something called peak performance. So if you run the application as a server for a couple of days or hours, it will optimize only those hotspots in the JVM code that requires that, while the boot speed is pretty bad. But in Kubernetes, we need to start fast because containers are killed and start much more often than it's not basically running for a couple of days. It's like wishful thinking. And it also has CDI support, so you can have dependency injection working with growl VM. That's the contribution of Quarkus. It supports or exposes some metrics for Prometheus that can be easily scraped by Prometheus. I will distinguish two types of the metrics. One is of the operator itself, and it says like how many Spark clusters we have created so far, or how many are currently running, and which are those, how are they named, how many workers are for each cluster. And it also can expose the metrics of the Spark clusters itself. This needs to be specified in the custom resource for the Spark cluster itself. So this is the example for the metrics of the operator itself. It also contains like how many log messages were there in the log file. So you can keep track like how many error messages are there. It can be useful for some alerting or indication that something goes wrong. Okay, so let me do a second demo for the metrics. This will be the more tricky one, harder one. I've prepared, because it will deploy actually a operator for Prometheus, so we'll have two operators running next to each other, one for Spark operator and one for Prometheus. The operator for Prometheus was created by CoreOS. Let me check if, yeah, it's deploying. And I can create custom resource for the Prometheus operator to finally deploy the operator, because the Prometheus operator isn't Prometheus itself. It can only deploy Prometheus. It's kind of overkill, but I like it. So I will be creating this list, and one of the item of the list is Prometheus. And it should also create Spark cluster. Yeah, it's right here. And it has metrics equal to, which will allow the metrics for the Spark cluster itself. So if I will process this list. Oh, I'm using this alias W, but it's nothing else than like watching for, it's like get pods watch. Like each 2 seconds, it will query the cluster, what pods are running. I should have described it before. So right now we are, it's still creating the Prometheus. And yeah, Spark cluster with 1 worker and 1 master with the metrics enabled. I need to, again, expose the route for the metrics. Oh, it was already exposed. And so it should be available under this URL. And I'm working with external cluster that's running in Brno, in Czech Republic. Let me check the status. If it, yeah, so perfect. It discovered both service, they call it service monitors, one for Spark master, one for workers, and I should be able to query for instance, the JVM metrics. So if I evaluate this, it says that I can actually plot it in a graph. So it's like very new cluster that was deployed, I don't know, 20 seconds or 1 minute ago. And it says that the master, where's the legend? It's a non-heap or heap area, and one is for master and one is for worker. And for those of you who are familiar with Grafana, you can basically also spawn a Grafana and have the much nicer dashboard in Grafana. I'm just deploying only the Prometheus. Are you familiar with Prometheus? Who doesn't heard about Prometheus? Cool. It's pretty much standard these days. It's scraping the endpoints with the metrics and stores internally in memory. So yeah, that concludes the second demo. Takeaways. Spark on K8s can be easy because it hides the complexity, right? Because you can either deploy a lot of manifests where you can make a mistake and you need to maintain them. For instance, if you are raising a version, you have to raise it on multiple places, while operator can hide the complexity. It can also provide automatic updates for you. It hasn't been implemented in the operator, but this operator was selected as a prototype where the CoreOS guys wants to demonstrate the capability of also updating the stuff it operates. And the idea is that it can easily make the deploys for you. Like if you deploy Spark in some version, and then you decide that the operator should automatically update it to the new version, it's totally doable in operator. While if you are using the customize or like plain manifest, it's pain. You have to do it on your own. While this is like real-time system that monitors your, in this case, Spark. The other message is that operators could be written in any language. The Golang is the most common, but is not necessary. Me personally, I prefer to have the same language for the operator and the system itself, because there's much bigger chance that you will find experts, that there's overlap in experts for those two components. I've created pull request to Spark, which is currently closed. I would like to get it merged, but probably it's like a very, very big PR that had like 5,000 lines. Probably it can be as a standalone project. And this is the repository of the code. And yeah, the slides are live in this. If you scan this code, you will get the URL of the slides. I will be much glad if you can contribute to the project. Up to you. Yeah. Thank you.
Okay, thank you very much. So we'd like to open up the floor. We've got just a few minutes left before we need to clear out the room for question and answer. I see one hand coming up there. I see another one there. I'm going to pass the mic around. We'll go here, then we'll come here.
Hi, Leo from Taboola. I'm wondering if it supports dynamic allocation.
Dynamic allocation of storage, or?
Of Spark executors, Spark
No,
supports
no, 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 it
elasticity
doesn't. It doesn't. You need to say in advance how many workers you need.
Okay.
But if the scaling is pretty fast. Like you can basically scale while it's computing.
Okay.
All right, great. Okay.
Hi. First of all, great overview, great speech as well. So
Thanks.
really enjoyed that. So just a couple of questions around the operator at the moment. So from a production environment perspective, does the operator at the moment support, excuse me, node affinity and sort of pod anti-affinity, i.e., if you wanted just say the master nodes on designated Kubernetes nodes?
Not currently, no.
Okay.
But it's a nice idea to have it, yeah.
Yeah. Okay.
For instance, if you have GPU pods,
Yeah,
it's a necessity, but it currently doesn't support it.
Okay. Great. Thank you.
Hi, thanks for the really great presentation. Following on the production ready side, how ready would you say the operator is to go to production with? Would you be fairly okay with starting a project on it and going all the way with?
Yeah, I would definitely suggest starting project. The code base is very simple. As I said, all the code base was 5,000 lines. So I don't assume that there will be a lot of bugs. The biggest issue is that there are missing features. But I think it's production ready. We use that in Red Hat for that Open Data Hub, which is like exploration platform for your data. We try to democratize the data in the teams so people can spawn their own notebooks. And Spark Operator is being used there.
Okay, another question over here.
Hi, very nice talk. So what I wanted to ask was, what happens to all the information that is, transiently persistent on a lot of these pods? So let's say the log information, the information of metrics that is stored in Prometheus, and the TSD time series database. What happens to that? Is NFS or shared drive the only solution, or what do you recommend?
It's not hard coded in the operator itself. Like you have to provide persistent volumes in the Kubernetes to be able to store the data persistently. Currently, the operator can't deploy the Spark masters or workers to stateful sets. And I was looking into that actually 2 weeks ago, and this is something that would need to be refactored to using stateful sets, because currently it's using just the replication controller, which says like deploy the master in n replicas or worker in n replicas, but it would require the refactoring to stateful sets. It's in our roadmap. It's the very next feature that will be in, actually.
Okay, one last question, and we're basically at time.
My name is Ramesh. A very quick question. I think you just answered it, but anyways, I'll try to clarify that. The artifacts distribution happens through the replication controller, is it, in this case? So for example, in Spark, when we run it on HDFS, the artifacts for the executors gets transferred through Yarn's native data distribution format. How does this work in Kubernetes?
Integration with HDFS is not perfect in Kubernetes.
No. I'm just trying to give you an example. But in K8, how are we doing it? Like when we want to distribute artifacts through Spark Submit.
Well, there was that example that showed like you can use the init containers that can you do the wget.
Okay.
There's also that Spark staging server, right? But I think it was deprecated, if I'm not mistaken. I'm not sure. Okay. There is no support for that staging server.
Okay.
But what we do in Red Hat, we use S3 buckets provided by Ceph. Also for checkpointing the Parquet files or loading the data at the beginning.
Okay, thanks. Thank you.
All right, everybody, please round of applause, and thank you very much.